All right, so we have another problem here. Ignore my scribble grays to the left. I have this originally as a multiple choice question, but I just want to solve it and walk you through it. So we have a only force acting on a 0.5 kilogram object as it moves along the x-axis. So we have some sort of object moving along the x-axis. The force applied or acting on it, this is saying the force as a function of x, meaning the x location it is at any given moment. This force is increasing as the object gets to increasing values of x. We want to find the force as this object moves from 1 meter to 3 meters along the x-axis. So if this is initial right here of 1 meter, then down here finally it's going to be at 3 meters. But if we were to represent the force, it's going to get bigger and bigger and bigger because x is cubed in this function. So this is a variable force. The force is changing as the object moves. That means we need to use our base equation for work where it's written in terms of the integration. We do need to integrate because this force is not constant. Now again, the dot product is multiplying the component of the force that is parallel to the displacement. This force is in the x direction, so we can just go ahead and put that function in for the force. And we can multiply that simply by dx because the object is moving in the x direction. So this portion becomes the x component of the force times dx. This force that they've given us is all in the x direction. So we can just plug that function in. Dx means we're integrating with x as our variable, which we can see that is the variable. Our limits need to be from the initial x position to the final x position. So the work will be, let's see, x cubed becomes x to the fourth over 4. So x to the fourth. And we need to evaluate that between 1 and 3. So 3 to the fourth power minus 1 to the fourth power. Grab my calculator. 3 to the fourth power. 81 minus 1, so 80. Now, the units need to be joules, which is in Newton times a meter. Where the units come from, if we come back to the force right here, this 4, the problem tells us this force is measured in newtons and x is measured in meters. So this whole thing, when we put in some number of meters and cube it, whatever units the 4 has, we need to end up with newtons. So the 4 needs to have units of newtons per meter cubed so that cancels with the meters cubed when we plug in an x value to get newtons. So when the 4 down here cancels out, we technically have 1 Newton, sorry, not 3, per meter cubed. And then when we plug in for x, we're going to have a meter to the fourth power. So meters cubed cancels with 3 of those. That is what leaves us with the newtons times a meter, which is a joule. So the integration in and of itself gives us the work done by that force as we move between those two positions for x. So variable force, we must integrate to find the work.